in the previous problems, there's a previous video linked below the like button in the playlist. We have this fx, we have this ln that we solve for, and then we solve for this log base. Now we're going to solve for this log base. We can see that it's different. What's the difference? Well, in this one, we just have log to a base, and then we have some number. Here, we have log to a base, some number, but we have an exponent. And this exponent is going to cause us to look back at our ln rules. We're going to have to memorize some things. So this is pretty cool, and I'll let my little assistant over here explain it to you.
Okay, so first we have to take care of log, because everything is like an onion, is the example that I've heard. So first you have to start on the outside layer, then the inside layer, and then the inside layer of that. So first let's start with log of 8, which from how we saw down here, log of bn, or the base, is 1 over ln b, and then ln to the number. So same
the number is primed, right?
Number is primed,
The
yes.
ln is primed, the last ln is primed.
Yes. So first we have 1 over ln 8, log turns into ln because that's our base. And then we keep this as ln x to the third plus x to the second to the third power primed, because we're not doing anything yet. This is our basis now.
And just like in the last problem, the only thing that changes is the exponent. So this ln 8, just as we've done previously right here, we can see that it stays the same throughout the entire problem. So that's important. You don't want to touch the ln part. We're only touching the second part where we're making derivations.
And here, instead of having the 3 go to the front here, we're going to actually put it in front of the ln because it's going to stay as a constant number. And now it'll be much easier to find the derivative of ln x to the third plus x to the second, because this little portion here looks like this portion here. So now we have an equation that we can put this equation into. So 1 over ln 8, parentheses 3 times. Now we have 1 over x to the third plus x to the second, because that is the same as 1 over n. Now we have x to the third plus x to the second, and the derivative of that, because we find the derivative of the number. 1 over ln of 8, 3, parentheses 1 over x to the third plus x to the second. We find the derivative here. 3 comes over, 3 minus 1 is 2, so 3x to the second power plus 2x, which is 2 comes down, and then 2 minus 1 is 1. X stays the same though, because x to the first power, x still shows.
And just to clarify, this is a derivation symbol. This is a derivation symbol. What we've done here is just as the previous one, we have 1 over n, which is this. This is our 1 over n. And just with this, we are not touching this anymore. We're not touching this anymore. And we're only looking at this part to derive. And so we are going to be deriving this, and that's how we get this.
And now here we combine the two equations. So we have 1 over ln 8, and now we have 3. 3 still stays consistent because we're just taking care of these two parentheses. So 1 times 3x to the second plus 2x becomes 3x to the second power plus 2x over x to the third plus x squared. Now here's where it gets a little tricky. Okay, now because we have, actually, there you go, that's fixed. Now that we have this part of the equation simplified, we have to simplify it even more. And when we have a number here on the outside, we only multiply the top, we don't multiply the bottom unless it's in another fraction. So we have ln over 1 over ln 8, and then 3 times 3 is 9, 9x to the second. You do not change the exponent at all, plus 6x 3 times 2x over x to the third plus x to the second. And then, now we finally do something with 1 over ln 8, and because, again, it cannot be multiplied, we keep it in a separate parentheses to the x to the third plus x to the second, and 1 times 9x to the second plus 6x is the same 9x to the second plus 6x.
Right. So this is a great simplification. What would make it even better is if you notice that in the denominator, we have everything with an x, right? So we have x is here, x is here, x is here, x is here. We don't need to worry about this because this is just being multiplied in. So what we could do is actually factor out an x, and then also factor out a 3 for our numerator. So we would have a 3 out here, and then it would just be 3x squared plus 2x. So this was okay right here. We would just have the 3 out front, and then we would just factor out an x. and have that in the denominator, because we would be factoring out just an x. And so that is it for that entire problem.
Toshiba. The way you said it, you sounded like your Asian heritage for once.
That's how it's pronounced.
Toshiba.
Toshiba.